representative of the startups can please come up on the stage.
Do you want us in an order?
Well, all of you will come up here to the podium, so.
Oh.
Sorry. We'll start in just a few seconds, so I know some people are still coming in from the lunch break, but we do want to get restarted, and the next item on the agenda is our second digital award, and we'll have each of the 5 startups competing for the award give a presentation, and after which you'll be able to vote. And so we'll just hold off a few more seconds as people come in the room. We're going to show the QR code for you to vote again before they start, just so you have it ready, because you will only have 2 minutes to vote, but of course give each of them a chance to speak before you vote, but we'll put it on the screen again for you just real quick, for you to put into your phone. Even I need to put it into my phone. And there you go. And it's for Slido. So just, voila. And or you can put in code 3305211 on the Slido website. Great. Then I think we will get started, so please have a seat, and we'll start with Ali Energy and Jonathan Carrier.
Hello, everybody. I'll start with the question first. How many of you have digital banking on your phone? Pretty much everybody. What happens if you could have an app on your phone that allowed you to have energy banking, where you could store, deposit, trade your electrons? Well, that's what Ali Energy is developing. We're creating an energy community platform that supports the trading, optimization, and distribution of electricity. And we do that with smart hardware. You can see the very small version on the desk over there on the table, along with AI and intelligent software that optimizes how that battery behaves based on where it is in the grid network. Now, what's really key with the solution that we've developed is not only that it can deliver bidirectional energy flow, which is unique from a piece of hardware, but also it's the intelligence and the software that allows it to optimize. And then how we're going to do that and turn it into this energy banking platform is through the virtualization of energy storage. So what does that really mean? Well, that means that basically you'll be able to rent 1 kilowatt hour of energy storage for €1 a month. Go figure with that. You could rent 10 kilowatt hours of energy storage for €10 a month, but then net off 30 to 40 euros off your energy bill. And what that really means is that we can disrupt the market for energy storage. We can make it 100 times cheaper than physical energy storage behind the meter, but also open it up to a whole range of new customers that have never experienced and will never experience energy storage, whether that's a small shop, whether that's someone that lives in an apartment, or anybody that rents. And for the DSOs, this is a much, much better solution than putting many distributed energy resources and batteries behind the meter, principally because that creates another challenge for constraints on the grid. And actually, with our solution, we can help the DSOs to be able to solve the challenge with voltage regulation and also to be able to manage and improve flexibility at the final substation. So how are we going to do that? Well, first of all, and this is where you have to bear with me because I know that you are regulated monopoly businesses, which basically means you're not allowed to own power generating assets, is to put one of those batteries alongside the final substation. In the UK, there are 586,000 final substations. That's just in the UK alone. Those are all connection points. If we put one of our battery solutions with our software there, we can provide you voltage regulation as a service, provide real and reactive power that helps improve how that transformer behaves, but also improves the quality of the power to everybody that's using energy at the end of the network. Then, once we do that, we liberate access to that energy storage through digitalization, allowing everybody to rent a proportion of the battery through their utility provider. And this will have a significant and dramatic impact because not only do we able to manage flexibility in a much smarter way, you can do that at a much lower cost for you as a DSO, but you can also automate it. I don't know about you, but my children, they don't want to be told at 5 o'clock that I can't turn the oven on so that they can eat, yeah? We don't live in a world where people want to be dictated to by the demand of flexibility. So instead, our solution is smart. It can automate that flexibility, bring benefit back of voltage control to the DSOs, but do it in a much cheaper and a much more efficient way. Once we do that, then we can create a whole new platform for energy storage and management at a hyper-local level, down to a postcode level, to facilitate transaction of sharing of energy intra-community, but also allow energy to be shared across communities. And that means you're just doing a PPA. So at Ally, we're really transforming how we liberate energy, but in the process, liberate energy networks from the constraints that it faces today and the constraints it will have in the future. Thank you.
And next we'll have E.DSO Energy, Peter Falkman.
Hello, everyone. So first off, I want to start with saying that you are not alone in the upcoming struggle with the electric transition. If you're looking at the World Economic Forum last week or week before that in Davos, the focus for the coming 10 years is going to be on the energy transition. We're looking a lot on, or the World Economic Forum is focusing on AI deployment, transparent and efficient use of energy for AI, innovation in technology, and also collaboration. And that's something that I want to come back to later on. E.DSO Energy, we offer a software platform based on dynamic rating of lines, cables, and transformers. This can enhance the grid flexibility of already existing assets, giving capacity gains up to 50%. Combined with our AI-driven predictions and scenario generations, we can offer the DSO or you insights into components aging, loss of life, assist in grid planning and investment decisions. We're also adaptable to other technologies. In a way, I would say that we are a collaborative technology. We have a project starting now where we're going to look at scenario planning and optimization of a large battery storage, and in connection with that, how the value chain continues into a virtual power plant. This is just a part where we see the platform being a base on which you can add a lot of different functions and also be that collaborative part. We can assist, for example, vehicle to grid. We can assist large battery storage. We can assist in large hydrogen production, offering better planning and also better capacity. This, of course, can also be a great assistance in building a more resilient grid. We see that, or it was something that I had a discussion during lunch today. And one of the focus areas that I said I'd come back to is the collaboration part. And in the conversation, the person I talked to said, but everybody's talking about collaboration, but it's not really happening. It's easy to say. And here we have something that is a very good tool, we believe, and a good start of how you can share data between companies and between parties in a project. And that is the federated learning. It's where you trade trained models instead of trading data. And if you want to know more about this and what Auto Energy is doing with our platform, please contact us after this. Okay. Thank you very much.
Thank you. And next from OGI, we'll have Muriel Etivon, Marketing Director.
Thank you. Electrical switchboards. Every building in the world is equipped with an electrical switchboard with circuit breakers like this one. It's strategically located at the heart of electricity consumption. And in the current context of energy, emergency, and usages electrification, this switchboard has a major role to play. Yet, it's limited by a 50-year-old mechanical technology, very, very far from the digital age. This is why we are developing a new generation of smart electrical switchboards based on digital technology. OGI is not just a switchboard. Far beyond security, its purpose is to enable smart and optimized management of electrical consumption at the scale of a household, a building, and a territory. For the user himself, OGI offers a digital interface, much more modern and user-friendly than the traditional switchboard with manual circuit breakers. It displays your electricity consumption for each circuit real-time. You may program it as well to automatically shut down specific circuits at night when you're away from home or during peak periods, leading, of course, to energy and cost savings. OGI may also automatically shut down a low-priority circuit to prevent exceeding the subscribed power. And of course, it can be controlled both locally and remotely, which enables multiple services, such as alerts in case of electrical incident or unusual consumption. But also it enables connectivity with integration to the grid. Smart grid integration will allow energy operators to collect comprehensive, accurate, reliable consumption data and feed systems such as digital twins real-time in order to take data-driven informed decisions. Priceless for consumption prediction. Network operators will also be able to regulate electricity flows. Today, we know how to offload some specific major industry plants at a given time. OGI will allow to extend the program to a significant volume of low-voltage sites. And I'm not talking about a blackout. I'm talking about offloading all low-priority circuits, such as water heaters, for 2 hours on a given large-scale territory. Hardly noticeable and painless. Likewise, operators will take advantage of carbon-free energy supplies availability to trigger batteries and electric car charging. At last, but not least, OGI is meant to be open source so it can seamlessly integrate with third party as needed. So where do we stand with OGI innovation? Before addressing smart grid use cases, the first step is to deploy the switchboard itself. We have validated the concept with a first prototype that we have presented to electricians. We have validated the technology by testing OGI digital tripping in the laboratory of Liège University. We are planning an experimental phase by the end of the year before going to market in France, and we are looking for partners for this phase. And since OGI addresses common European electricity regulations, we will be able to extend fairly easily to other countries. So, as you may have understood, our main drivers are to help us, individuals, mastering our electricity consumption, but also the community by providing a flexible solution to optimize power flows and leverage as much as possible carbon-free electricity production. Thank you.
Thank you. And next from SenseWaves, we have Fivos Maniotakos, CEO.
Thank you. Hi, everybody. Thanks for having us. I'm Fidos Maniatakos. I'm a CEO at SenseWaves, and what we are doing at SenseWaves is dealing with the problem of lack of visibility and situational awareness in the distribution grid. And this is an important problem to solve. I cannot stress enough how important it is, because we can talk as much as we want about future grid scenarios with renewables, with EVs, with data centers, but everything passes first from one simple fact. We need to understand very well how the grid behaves, and actually not as a set of individual assets, but the grid as a whole. So, and believe me, solving this problem is not the easiest thing. We have been working together with the DSOs, trying to identify the different issues, and we came up with the 3 main areas that we needed to focus on. So the first one is the lack of connectivity. So lack of connectivity means that DSOs, they usually have a GIS. They know very well where their assets are, what they do. What they are not sure about is how these assets, these different assets interact the one with the other, and how they work together. So this is the first part. But yet, I mean, it's very important. So the second one is the lack of observability. We have a lot of assets. We have a lot of assets on the grid and a lot of monitoring equipment. But I mean, let's be honest, we cannot have monitoring equipment all over the grid. It's just impossible. It just took us 10 years to put the smart meters. And still, I mean, there are so many assets that are unmonitored that are playing a very important role onto the grid, and they have an impact that needs to be assessed. And the third problem that we have identified is lack of data readiness. So data generated by the grid, I mean, it's massive, but it's raw data. So for an engineer, a grid engineer, raw data is simply useless. What they need instead is insights that they can act on. So we have provided solutions to these problems one by one. For the connectivity problem, we created a system. It is based on AI that is able to repair the GIS. It is able to find the missing connectivity, not for one, but for all of the assets on the grid, and produce a connected digital twin. I stress the word connected. So we really cracked this problem. We have 98% of accuracy in finding connectivity for every asset. And still, I mean, the most important thing is that this is a project that usually takes 2 years to accomplish. So we do it automatically. So we are able to do it in just 2 weeks. And the second part is the lack of physical meters around the grid, where what we did was to create virtual meters instead. So we are estimating load flows. They are very accurate because we leverage our connected grid model. And we simply use the smart meters and estimate the load flows all the way up to the substation, but for all the assets in between. So at the end, I mean, we don't run, again, these load flows 1 per month. We run it continuously, store the information, make it available for future use. And these virtual meters are 95% accurate, but still, I mean, we have meters, virtual meters all over the place, places we wouldn't see a real meter in years to come. And the last part is data. So we have created the necessary methods to provide insights for a number of different departments, from planning to reliability and asset management. So yeah, long story short, so we have reached a level of maturity. We are in 5 different continents, 8 large deployments. We have a lot of success in the USA, being in 5 states there. We won the award last year in the US for the emerging technology provider. And still, I mean, we are a European company. We want to work more with European DSOs. So yes, European DSOs, please come talk to us. Thank you very much.
Thank you. And then finally, we have from Tether, Luis Medina Rivas, CEO.
Hi, everyone. My name is Luis. I'm the founder and CEO of Tether, and we turn millions of electric vehicles into a green asset for the power grid. So what does that mean? As we all know, we're moving towards more renewable energy, which is fantastic. But as anyone who's been in Brussels for the last 2 days can attest, the sun doesn't always shine, right? And the wind doesn't always blow. That intermittency in power generation is a huge problem for the grid operators, especially when coupled with the electrification of assets. So if it gets bad enough, it can lead to a total grid blackout and many other problems. And so to avoid that from happening, every single day we pay millions of euros to fossil fuel power plants like gas turbines to stand by just in case they needed to ramp up or down their production and keep up with the intermittent demand. Not only is that incredibly inefficient and costly, but it undermines our carbon reduction goals. So this is the big picture, right? Transmission level. What about the distribution level? I learned the problems firsthand when I was working at General Electric as a solar design engineer. My job was to design and build large-scale photovoltaic projects and get them connected to the power grid. And I really liked my job, but the most frustrating thing about it was the sheer number of projects that I didn't get to build precisely because of grid capacity constraints, voltage flicker constraints, and other things. So the feedback was always, what if you could add batteries to your solar panels, right? But the problem with batteries is they're expensive, and a lot of times they kill the economics of a renewable energy project. So to make the long story short, one day as I was walking past one of the canopies that I had built on a parking lot and saw the thousands of cars parked underneath, it hit me. When all of those vehicles become electric, they're essentially just going to be big batteries on wheels. Each one will consume 3 to 5 times the power of the average European household. And with 130 million electric vehicles being sold in Europe alone over the next 10 years, all of the energy storage capacity we could ever need is literally going to be sitting on the streets waiting to be used. And that's where Tether was born. We basically turn millions of parked electric vehicles into the world's largest distributed battery for the power grid. In short, we build sophisticated AI that learns, predicts, and optimizes how and when electric vehicles charge in relation to each other and what's happening on the power grid. That allows us to bid the explicit flexibility of those assets on the 30 billion euro balancing markets, which is where we make our money. And then we share part of our revenue with our partners for letting us connect in the first place. So we are a white label back-end solution. We partner directly with charge point operators or the vehicle manufacturers such as Audi. And essentially, we turn part of the problem into part of the solution. Speaking of partners, we currently have a proof of concept with Audi. We're working alongside a couple of other car manufacturers such as Seeker and Volvo. We are launching some POCs with multiple transmission system operators across Europe. But we're here because we're looking for partnerships with the distribution system operators. We think that the problem of flexibility of electric vehicles is even more acute at a distribution level, and we want to be working directly with partners here to find basically pilots and solutions that work at all levels of the grid. So thank you so much for listening, and yeah, thank you.
Thank you very much to all of the participants in this award. And now it's time for you to vote. So use the QR code or go to the Slido website and enter the code 3305211. And the clock is counting down. We have 2 minutes. I see 55 people have voted, 56, so it's increasing. Good. Be great if we get at least 100 votes, 100 people participating in the voting. Last 30 seconds. I see votes still coming in. That's it. Voting has ended, so we'll disclose the winner. So this is exciting. Let's see who the winner is. And the winner is Tether. And so E.DSO is happy to present you the second digital award at the FutureGrid. So congratulations.
Thank you, everyone who voted. Lots of great startups here. So it's an honor to be selected, and hope to be talking to you after this. We'll be at the booth there. So thank you so much.
Thank you. And we have a certificates of recognition for our other finalists. So please come up, Ogji, Sense Waves, Ally, and Atto. So let's come together for a photo of all of you with your certificate or with your award. Yep. Many congratulations to you. So thank you very much. If we finish the photos, I think we finished the photos. Okay, good. So then I will let you all exit the stage, and we'll call Prismian Energy to come up after our awards competitors are off the stage. And now I'm honored to present our sponsor, Prismian Energy, and Cinzia Farisei, and as well our member, Enel Grids, represented by Massimo Bartolucci. So please, Cinzia and Massimo, please come to the stage.
Hello, nice to meet you. Hello again. Hello, good afternoon. I'm Massimo Bartolucci, of course, from Enel Grids, and jointly with Prismian, we are telling you a long story of collaboration. We addressed 3 topics that are of great interest for distributors, and of course, I will give you the perspective of the distributor, and later, Prismian Energy will give you the solutions that we have developed together. Okay. Let's start with the first topic is the grid impact as far as the carbon footprint. In NL, we, of course, calculated a few years ago, we calculated the grid impact by component. We made a deep, accurate study, and we discovered that multiplying the CO2 impact of each component for the quantity that we supplied, we had cables and conductors at the first place. We also, you see, we have an estimation for each one of our components of the carbon footprint, the average one at least. And so we found out that, of course, cables are the most impactful, the most important component as far as the carbon footprint. We went also deeply inside. Of course, we made a material breakdown of our cables. Could be Prysmian cables, of course. And what we found is that even though they are, as far as the material breakdown, they are compounded by metals, polymers, and of course, the manufacturing part, the most part of the carbon footprint was given by the aluminum. So you see, we also identified which actions in terms of green metals, green production of polymers, improving of the process, had to be brought into this component, the most impactful one, in order to lower the carbon footprint. Okay, let's go to the second topic. Second topic, of course, is energy transition. We heard a lot this morning about the growth that we are expecting in energy use and in the energy to be distributed and delivered. And of course, as distributors, we have to speed up construction, to have efficient ways to improve to the capacity of our grid, to have less losses in a short time. Of course, we explore technologies that can achieve this goal. We try to test and to verify the effectiveness of these solutions. For instance, I put in the slide just a couple of examples of new technologies that adopted into the medium and low voltage grids could bring to an effective improvement. For instance, advanced coatings for the conductors, able to less absorbivity and better emission in order to keep cooler the conductors. Of course, better if applied with robotic technologies. And of course, the other technology well known in high voltage, but not yet applied in medium voltage, is the high temperature, low sag conductors. Last but not least, the underground network reliability. There is a lot of talking about the underground in the networks. We know that this is a solution for a lot of problems, but underground network could bring problems in terms of reliability. 70% of the faults in underground networks are due to accessories, to joint faults. And when we talk about the joint, we talk about a component that can be small in dimensions, and even the cost, of course, and not so, we could say it is affordable. But the damage to the grid in terms of reparation, activation, localization of the fault, excavation, restoration, can be huge. That's why we want to address this problem. We need reliability in the underground network and into the accessories that we use in the network. Talking about joints could seem a simple component. Nonetheless, if we want to identify the causes of fault, we have to identify the manufacturing of the joints, the design, the technology, the materials, type testing, and the quality of the inspections. And also we have to investigate the installation phase. Installation phase happens in field and implies people qualification, implies procedure updates, commissioning procedures. So it is not so simple as it could seem at the first glance. We need, of course, to bring into our operations commissioning, validation procedures in order to verify that even such a simple component, once installed, is properly installed, is reliable, and can last for all the days that we plan it to stay there. In the end, also talking about underground network reliability, of course, we are foreseeing a huge number of installations in the coming years. This could bring problems if they are done manually. So probably application in robotics into the grid manufacturing could bring for sure a huge improvement in the reliability of our future networks. That's it for the moment, so I leave the floor to Cinzia with the solutions that they have prepared.
Dear partners and distinguished guests, good afternoon to all of you. Honored to be here. Thank you, Massimo. Dear Massimo, for being with us today, for your clear message. The clear are the messages from the E.DSO. The most effective and appropriate is the answer that the solution provider can apply to the grid. This is, in a nutshell, the essence of the Prismian collaboration with Enel, but also with the main power utility in Europe and in the rest of the world. A world that is changing. Someone this morning was speaking on the new era of electricity, it's true. A world that is demanding, that is introducing some opportunity, is true, but also huge challenges in front of the grid, and the partnership here is essential. And this is the scope of this short presentation. I will provide, not to enter in each and all technology that we develop with our partner, but just to have a flavor of what we are doing to support this rapid change, this new necessity of the grid that is introducing partnership because by definition, innovation is something that we don't do alone if we want to implement into the grid, a grid that we want as the final consumers more and more flexible, more and more resilient, for sure, more and more smart. Let's see if we progress. Good. So Massimo was mentioning the three important topics for Enel: grid carbon footprint, grid enhancing technology for the grid, and grid reliability. And here you see on the right side of the slide what we as a solution provider and not only as a cable manufacturer, we were offering to the grid. To reduce the carbon footprint, to enhance the grid technology, to improve the grid reliability. All this while one of the targets we fixed in our partnership was also and is to mitigate risk through innovation, risk of supply chain disruption for grid component, risk of lack of adequate skilled labor, risk of project delays, of regulatory framework, and also on social license. and community acceptance. Let's go to the first chapter of our roadmap innovation. When we speak about reducing grid carbon footprint, we mention here 4 big initiatives activated. One is related to the green aluminum to reduce the carbon footprint up to 70%. While we are producing cable with less than 4 tons of CO2 per ton of aluminium, we are exploring in this period, in this moment, aluminium with less than 2 CO2 emission per each ton of aluminium in terms of carbon footprint. In the same time, we are developing recycled aluminium and copper to improve circularity. We are doing with our partners, with our suppliers, we are doing also with our customer while we focus on the end of life of cables. We were introducing biomaterials with negative CO2 emission. We are proud to say that in 2024 we supplied more than 58,000 kilometers of cable, incorporated bio-based materials, which are reducing carbon footprint as compared to the conventional oil-based polymers. The last initiative in this sense is the recycled polymers. We are also implementing at global scales circular material that are continue to meet, obviously, the cable performance, including the different layers of the cable, outer sheet, semiconductive layer, and the most importantly, insulation of thermoplastic cable. And the king of this chapter is, in terms of solution, our P-Laser, which is a totally eco-friendly cable that is operating at plus 20% temperature with 100 eco-friendly materials, fully compatible with the grid, that is today a standardized solution together with Enel in Italy, but also we introduce in Romania, in partnership with Enel, and we are launching in this moment with E.ON in Sweden, as well as we have some pilot project in progress in Germany. Looking at the second chapter, powering the energy transition with enhancing technology, here I would prefer to mention few solutions. The first one is the high temperature solution for overhead lines through HTLS and aluminum zircon alloy for extreme temperature, but also for the underground network, the P-Laser. New design for large size conductor, both for high voltage cable up to 3,500 millimeter square aluminum, and for medium voltage cable up to 1,000 millimeter square aluminum to reduce losses and carbon emission, but also new material and design for medium voltage DC cable. This is extremely important, is something new. We implemented the new material and specific design for medium voltage DC cables that can now be tested with our partners. We also improve the electrical conductivity of metals in collaboration with some university in US, where we are developing solutions to improve metal conductivity, but we are also increasing thermal conductivity of polymer in order to reduce losses and carbon emission. Here, the king of technology is E3X. I think Massimo was already introducing a bit the topic. Is the first heat dissipating overhead conductor with the durable coating applied on the surface. It is also accompanied by the first robot system cleaning and coating existing overhead line. We can say proudly that this is a technology that we are applying in North America, where 30% of the business of overhead line made by Prysmian is with this technology. We have ongoing pilot project in LATAM, in Middle East, in Australia, and we are now introducing also in Europe. This is just to mention that as it is important to build a new line, it is also important to make the existing one much more effective and resilient. For the third chapter, which was introduced by our partner, by Massimo, improving underground network reliability. Here we have a few different solutions that we want to share together with you. The first one is related to our technologies for monitoring, grid, and also for preventive maintenance. But also, we develop smart joints with the sensor embedded, and we are developing smart cable with tag embedded. This is extremely important because obviously with our LSPDS we can measure partial discharge and other critical parameters to prevent failures. But also with our smart cable with tag, we can develop cable with smart tag under the other sheet to digitally store information on cable record, precise location and installation detail. Another extremely relevant need coming from our partner was related to the necessity to improve underground network reliability, especially related to the joints, as a critical component of the grid. Here we are robotizing our jointing activity. We develop a fully automating jointing robot. We call it splicing machine. This was benefiting this initiative, is a great initiative that we are making in cooperation with Exelon and Con Edison in US, benefiting from an important contribution from the US Department of Energy. And this is a breakthrough innovation when it comes to joint automatically cable with advanced technology, which helps human to operate the machine remotely from a safer environment. This is something extremely innovative if we think that we estimate to be able to reduce network failure from 60–80%, as you were mentioned, Massimo, up to less than 5%. This is obviously dramatically improving the workforce safety, reducing our cruise time in underground vaults, but also increase reliability and stability of the network. The prototype of this innovative solution will be ready by end of this year, and we suppose it will be able for testing on the field early 2026. A second important chapter when we deal with improving underground network reliability is also related to empowering people potential. Someone this morning was making clear how manpower is and will be more and more in the future in front of this explosion of the necessity of the electricity worldwide, more and more crucial for the future. So we decided at Prysmian Group to launch in partnership with all our people in the different regions of the world, a Prysmian Grid Academy, a global academy that will shape the sustainable leader of tomorrow, will continue to support the grid value chain while boosting innovation. This academy that has the purpose to nurture knowledge, preserve and certify, and extend the skill base while foster a multi-level grid community will be operative by mid-25. It will be open also to power utility and external participants by the end of the year. With this in mind, I think that we all, coming to the conclusion, we all agree on the fact that the distribution grid is expected to handle much more in terms of current volume in the next 25 years. Someone was saying the International Energy Agency was speaking on 3 times the current volumes. In this context, we think that the role of the solution provider as Prysmian is key in collaborating with the utilities in order to provide answer to new needs, but also to accelerate the transition. The solution provider can reinforce the commitment of working together in boosting a power grid ecosystem that is requiring the support of all the actors of this ecosystem, and the partnership in innovation we have with Enel, Prysmian Enel, is certainly an effective step in this sense. Thank you.
Thank you so much. And now we come to our last panel of the day, and I'd like to call Josh Roberts, the moderator, someone I know quite well. And I'll let Josh introduce the panel.
Yes, thank you very much. Thanks, Charles. Yeah, him and I go way back. Like I do with many of you, introducing everybody to what I work on, which is energy communities. And I must say, you guys are quite bold, bringing me up here to help lead and facilitate your discussion, because I am probably part of the subject matter of what we are talking about here, which is consumer engagement. And of course, that term is very loaded, and we will unpack what it means throughout the panel here today. Just to set a little bit of the context, and then I will invite the panelists up. I mean, we're talking here today about innovation and the role that DSOs and different technologies can play, all of the amount of investment that is needed. I think this is a topic that you guys have explored very deeply up until now. But there's also another angle to that, and that is the consumer side. And we're not really talking about the more advanced consumer here. We're not talking about industrialized consumers, consumers with large loads. We are talking about what I would like to describe as the high-hanging fruit, the smaller customers, the ones that have different needs, who want to do different things with the grid, sometimes things that the DSO doesn't always understand. But again, I'm grateful for the trust that E.DSO has put in me to lead this discussion, and we'll see where we're heading as we head, of course, into the future. So without further ado, I will invite my panelists up here. First of all, David Peters. He's the Chief Transition Officer. He's a member of the board of Stedin, and he's Vice Chair of E.DSO. My next guest up here will be Marcia Poletti. She's the head of European System Change at Octopus Energy. Tara Esterl, she's the head of competence unit of integrated energy systems at the Austrian Institute of Technology. Come on up. I feel a bit like a game show host. Next, I'll ask Lola Acreu Garcia. She's the senior project manager for ETRA, and she will be presenting the project Eclipse. And last but not least, the voice of the consumers, Laurent Rutten. He's the senior policy officer for BEUC, which is the European Consumer Organization. Yeah, thank you. Yes, there might be a prize at the end, or not. All right, so I've sort of laid out the context for you guys, and I think we're going to jump into the meat of the matter, and I just wanted to give you guys each an opening opportunity. We're going to start a little bit easy now. I'm going to hand it over to our hosts for the first intervention. Please introduce what you do, and specifically, what are we talking about here when we're talking about how innovation and technology can be promoted, and what is the role of the DSO in doing this and engaging the consumer?
So thank you. My name is David Peters. I'm on the board of Stedin, and I'm a vice president at E.DSO. And I'm on the board of Stedin as Chief Transition Officer, so that means that I'm full day busy with the energy transition. And that means that I'm busy with the digitalization of the grid, but also with the investment planning, and thirdly also with new models around how we're going to deal with the grid. So I feel at the right place now at the moment to talk about. And I think, as you all know, in the Netherlands we've got a quite challenging situation on the grid. And we do have a lot of congestion in our grid, but that's, of course, caused by a good sign. So I think we've got one of the most PV per household in the world, actually. It's in the Netherlands. Electrical vehicles is one of the highest, I think, after Norway, in Europe, etc. Number of charging poles at around 30% or something like that in Europe is in the Netherlands. So there's changing a lot, but also it really challenges our way how we think about the interaction between the grid and its users. So let's say it's not only about consumers, but it's also about industry players, etc. And I think we're really looking to a paradigm shift where we are trying to get a new energy balance, the way we interact and use our energy, at which moment. It makes a lot of, it's really important at what time in the day you use your energy. How much can you shift it or not? Is there an incentive for it? Is it easy to use? So that's where we're in the middle of, in the Netherlands. And that's what I would really look forward to talk about in this conversation.
Great, thank you, David. I will hand it over to Marcia, who is probably one of the enablers, or at least your company is helping enable consumers to become such a player as they have. I think if the Netherlands is the most, then we are kind of also looking to the Netherlands about what our own countries, regardless of where we live around Europe, what might become. Can you respond to David and maybe provide a little bit of your perspective on how we can empower, and what type of consumers are we actually trying to focus on, or even a little bit more difficult than some others?
So it's a really interesting question, because I think where the Netherlands is going, the rest of us are going to be following very soon. So we really need answers. And I think for me, if we think about innovation and if we think about customers, three things stand out for me. The first is, arguably, we don't need any more innovation. There are lots of great ideas out there. We just need to implement them. And actually, we need to unlearn something that we learned at school. At school, we were told it was cheating if you copied your friend. Now, we need to be looking at what works, and we need to be rolling it out really quickly. So less innovation, more implementation. The second thing is, we talk about empowering customers. And I think we often have a paradigm in our mind when we talk about that. We imagine these really active customers who have got an app in their phone, that they're trading electricity all day. Tell you what, there's a whole lot of people out there who have lives. You know, they've got kids they're picking up from school, they're doing birthday parties, they've got jobs. You know, it might surprise you at E.DSO Energy Innovation Summit, because we're all energy geeks, but actually most of the world isn't. We launched a dynamic tariff for customers 4 years ago in the UK, and there are people who absolutely love it. But our most popular offering for customers is where we just tell them,
look, you let us steer your EV chargers or your EVs or your heat pump or your battery. You tell us what parameters, what's the top temperature you want your house at? What's the bottom temperature and what do you want it set at? Tell us that once and then forget about it. You can always override it. But in exchange, we'll give you power that's 70% cheaper. That's a 7 with a 0 after it. And that's what we mean if we talk about the energy transition. It's making it cheaper and better and simpler for consumers. And then as soon as we do that, we can then come to Stedin and say, and this is my third point, tell us what being grid-friendly means, because we can do that. So if you give us a price signal based on your day-ahead model of congestion, and we can help you with that too, or you can go talk to Volue, or you can talk to myriads of companies out there who can build AI-powered congestion models, give us a day-ahead price signal, and we'll move our smart load from out of those times that are congested. It's actually really simple. Because if you did those three things, I guarantee you the rest of the stuff will happen, and we'll get a cheaper energy transition. And yes, we're going to have to build a little bit here or a little bit there, but the key thing is we'll start using assets properly. We'll give consumers what they want, and we'll make this transition happen.
All right, so it's not the first time I've heard that we have enough innovation and we don't need any more, but controversial, I think, in and of itself to get it started. Maybe, Tara, I'd like you to maybe respond to that. Coming from Austria, you also you have a front seat to some of the, I guess, socially innovative things that are happening on the ground there. Would you like to tell us about that?
Perfect, yes, thank you so much. And I really, really have to agree with you with on all the points that you've said. It's really great. Yeah, I've done a lot of research on the topic of demand response. How do we get the consumers to engage with grids, with markets, and how do we get them, and how do we design these tariffs? And I fully agree with you. The tariffs have to be easy. They have to be understandable. We need to make them so simple and easy accessible that we have really good, great apps to reach the people who really want to interact, but also to interact really easy with the energy management system, really have a simple connection point that we really get the tariffs to the energy management system, that we reach everyone else who just want to have it automated. And we also should give the control to the consumers. They really like to be in control. They really want to have this big red button to say, in the end, no, I want to out. Most of the time, they don't do it. They just want to have the feeling of control. And I think when we have grid tariffs and tariffs, dynamic tariffs, where we leave the control with the consumers, it's easier for them that they say yes in the end. And at the moment, we are still doing research. So I think we have not solved all, but a lot. And we are designing at the moment 3 new grid tariffs. We want to make them somewhere simple, but also complex enough to really solve the congestion problem. And we're setting up 3 new pilots at the moment in Austria, where we want to, we will start in 3 months roughly with the demos, and we want to test these 3 different grid tariffs to see if they work and how to get the most of the consumers engaged. And we also want to test then how can we bring the grid side and the energy side together, because I think the consumers will be quite confused when they get a different signal from the grid and a different signal from the markets. So we should somehow get these 2 worlds together and send in the end then like 1 signal to the customer, or perhaps 2 signals, but then the energy management system makes 1 signal out of it, 1 understandable signal. How we bring these 2 worlds together, I think, is one of the parts that we have not solved fully.
Thank you, Tara. Lola, would you like to come in with some of the experience that you guys have had from the project that you're working on?
Yeah, actually, I'm Lola Lacreu from ETRA. I'm the project coordinator in this moment from Eclipse project. It's a digital Europe program project, but I've been working in the in the smart grids projects and solutions from 15 years ago. So at the end, as also mentioned by my colleagues, what is important here is to highlight that both operators or market grid operators, market operators, and consumers should get benefits from this. Win-win situation is what we're going to get. So from one hand, the operators should really get the impact of increased flexibility into the grid. And at the same time, the consumers should also have this trust of the operators, should trust on really receiving the good information on time, and also to have the power in order to really participate in the market. So that's very important for both of them to have the feeling that they are crucial and they are getting benefits, and at the same time they are an active part of it. In Eclipse project, what we are providing is a common European framework for energy monitoring application for domestic consumers. So one of the tricky things here is the importance of the interoperability, and also of the data, of having all the required data from consumers. And from this, we don't need the operators and retailers in order to provide this data properly. So first of all, it's not only that they need to have some benefits from this, but also they need to have also the digitalization of the grids. Of course, smart metering and IoT solutions are needed for this. And also, end users should have, as also mentioned by my colleagues, to trust and to really have the feeling to get these services in an easy way, to participate in the demand response programs and in the flexibility of the grid in an easy way, that you, with a easy and standard open source application, you are able to participate, to be an active part of your consumption. That's a terrific thing. And for this, also policies, regulatory framework conditions should be aligned with both protecting end users in this case, but also the operators.
Mm-hmm. Okay. Thank you very much. All right, Lawrence, you've heard all of the pitches. Are you sold?
Yes, actually, the previous speaker saved me a lot of time because I can ditch part of my speaking points and go a bit freestyle. So yes, my name is Laurens. I work for BEOC European Consumer Organization. We represent consumer organizations from all over Europe, EU, non-EU, to the EU institutions. And our weird acronym comes from our legal name in French. And I would actually start with this perception that Marcia also shared, because I started working last June on energy. I shifted teams. And I was asked in a span of a couple of months, what do consumers feel about the grid? Some people may have feelings about it, but I think we need to recognize indeed that you cannot be a consumer 24/7, and today we're talking about the grid, but my organization, we move from food labeling to chemicals legislation and the safety of products, and we cannot know about everything. So I would very much underline what Marcia said. We have looked as an organization at flexibility for many years. We did the econometric modeling, yada, 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 but now we want to look beyond this and look at the practice and how we can use what already exists indeed to what can be copied from one country, from the countries that are more advanced, to other countries. On maybe one aspect before I go into two examples, we have the grid charges debate. As a consumer organization, I have to say here that, of course, the fair allocation of costs is crucial there. And Tara actually taught me something that I am actually not going crazy, because I've had the same questions about the different price signals and people telling me, oh, don't worry about this, it's not the case. So thank you for affirming that this is something we do have to look at. What are we doing now? Well, econometric modeling has been done. Business cases are there, the players are there in some European countries. We're looking at the role of consumer awareness and basically everything that follows at the decision-making process and how that can influence the uptake of flexibility in order to help all of you, well, most of you who are working for the grid, so to say. And there's two pieces of research from the UK that are interesting. One is from which is the largest consumer organization in Europe, and they looked into the consumer experience with smart electricity tariffs based on interviewing people that have them already or are considering to get them. Well, there are many, many, many aspects to this, but it goes from being aware of their existence to looking into them and to deciding. A lot of conclusions, but one that I found interesting is that a lot of people are influenced by people that they already know being on a tariff and having good experiences. We see this actually in other consumer sectors as well. For less active consumers, actually proactive outreach by their supplier was apparently a reason to engage. Not necessarily maybe to get it, but at least to investigate. At the same time, of course, there are still many people who are not aware about flexibility, or however you want to phrase this in normal speak. That's still something to be resolved, but there are ways to engage consumers here. The research is, by the way, much broader, but I can't go into depth. Another consumer organization from the UK called Citizens Advice looked not necessarily at the price element, because price information is usually a thing that comes up when you talk the consumer, but they went into factors that could influence consumer uptake of flexibility beyond price. So neurodiversity, physical health needs, literacy needs, household composition, and they formulated recommendations towards the UK government on that basis. Taking that into account, we now in Brussels at BEOC find ourselves in a situation where there's been a lot of legislation. Josh, you will attest to that fact on electricity markets. We now want to take those experiences that exist, and our members have also asked us, can we please comparability approaches? What is working? What isn't working? What can we bring from the UK to other countries? And we're running actually an internal survey about this. I'm not sure if it will become external, because it's also just understanding each other's electricity markets and that kind of stuff. But that's the direction we want to go, and see basically how we can help consumers, maybe not all of them, but many of them, make the most out of the market.
Mm-hmm. Okay. Yeah, and I think maybe also just to provide an idea of the magnitude we are talking about, in 2015, ResCoop.eu, along with some other organizations, funded a study, and they showed that by 2050, at least 45% of citizens, EU households, could own renewable energy production. So about roughly around 45% of renewable energy production would be in the hands of citizens. But the even more interesting number was 83% of them would somehow be involved in the energy system, whether it's through demand response, using EVs, connecting to them, connecting to the grid, etc. I mean, David, what sort of thoughts does that, that's in 2050, and we're now. I mean, where do we bridge the gap there in terms of what our needs are for, not just for innovations, but also engaging this, out of this 83%, we're talking about almost an infinite number of groups.
Yeah, it's a huge number, and that's why I said there's a kind of a paradigm shift, and it's not only for the DSO, but it's also for the regulator. It's for all parties in the supply chain. It will be different how we're going to deal with our energy supply, with the grid, and what the involvement of the consumer will be. And then your question, what's the gap? How do you bridge the gap? That's, of course, the $1 million question a bit, but I can highlight it a little bit from the perspective of a DSO. And I think one thing I've learned here is that it's don't think your way in your acting, but act your way in your thinking. And that's, we have to keep on moving. It's so important. And as a DSO, I speak now for my own company, but probably a lot of people recognize that we really want to understand, is it safe, etc. But we should move with 50% MVPs to see how it works. And in the end state, in 2050, it has to be safe. We have to keep on moving. And what are we doing? What does moving mean, to move, to bridge the gap? So I think a couple of highlights over there. I think, first of all, a DSO can't do this alone. You need to collaborate with parties who have easier access to consumers, who have better propositions over there. And it's what I found very interesting, the actors where you collaborate with are changing over time. And that's really fascinating. Like the grid is still there, but the people you're looking for to collaborate with are changing. And you have to keep on doing that. I think the second thing is already mentioned a bit. You have to supply data. You have to explain what you need. And the interesting part here is we talk about grid-friendly flexibility. And yes, that's true. But what I've learned the last couple of years is that what is very easy to understand, to say, oh, this is our peak in the grid, it's changing also all the time. So it's really about interacting with your open data. It's not only opening your data, but it's how do we interpret this data? It's very scary to just give the data and then see what's going on. That won't work. It's about collaboration here. Being transparent, but also finding ways to collaborate on the transparency over there. And I think the third one, I completely agree with the fact that we have a lot of innovation already done. And it's about getting it in place. But still, you can do a couple of pilots which are really moving the needle. So I give you one example. So we have got a huge building development in the Netherlands, and there was not sufficient grid capacity for the complete area. We talk about a lot of houses, a lot of businesses, schools, etc. But we couldn't facilitate that because there was not sufficient grid capacity on time. And we just asked everybody in one room and said, okay, can we make this work with all the technologies which are already working today? So, and we made it just working within the budget of the grid capacity which was there available. No new technologies, just a different way of working together. And really key here was the consumers should be just able to do what they always would do. And we managed to do that. And that is really, it's a pilot. It's the first time the regulator said, okay, you're allowed to do this because we had to follow different rules, etc. But by doing this pilot, we moved the needle on what was allowed from policies and how we framed the issue like, how is it possible to move ahead? And I think these type of pilots, they turned into new policy very quickly.
Yeah, Marcia, maybe that's a good segment to you, Marcia. I think because we're talking about regulation being more innovative to meet the new emerging practices and business models, and maybe Marcia, you can say a little bit about how it is to be one of the innovating companies in such a landscape where you don't necessarily have the regulation in place, and I guess somehow a different willingness depending on where you are to have sort of like a regulatory sandbox like they did in the Netherlands.
So I recognize what David was describing there, and it's really interesting that when the electricity system was first being constructed, it was this really vibrant, fast-moving entity. You know, you had different frequencies in different areas. You had, you know, it was all sort of evolving and converging, and we've hit a period in time where things have frozen in place. And what David described is a sort of unfreezing of exploring possibilities. And actually, we as a company can't innovate without DSOs like Staden. You know, so we're working with Transnet BV in Germany. We're working with DSOs here in the UK. We'll work with any DSO in any country we're in because that's the only way we can drive innovation through. And yeah, because the rate of change is so quickly, again, what David's describing is where you need the regulator to be sitting in the same room at the same time as we're generating different ideas. This idea of we need to move to a world of co-regulation where we're regulating with industry, with the grid operators, with all the market participants, because, you know, things are changing really rapidly.
Yeah, and maybe I'll use this opportunity to bring you in again, Tara. Again, coming from Austria, I've looked a lot at Austria. They were one of the front runners in setting legislation for energy communities and by de facto kind of energy sharing, which is one of the more disruptive activities, I would say, at the moment. What do you have to say about that experience?
Back in 2017, when I first heard about the energy communities, I had been working quite some time on the topic of demand response, and I was a little bit, it's not so easy to get these consumers to interact. And I really don't understand 100% why, but they are super interested in energy communities and much more than in demand response, perhaps because it's much more easy to understand the concept. So we have, like, in Austria, we have now more than 1,700 energy communities. So, and we're quite a small country, so this is really a lot of energy communities. And at the moment, it's still a lot of metering concept, so it's not 100% a sharing and automation and control concept. So what we at the moment doing is bringing this momentum that we have in Austria in the direction of really to have grid-friendly energy communities then in the future, because I think that's really important that we take this vehicle of energy communities, make them grid-friendly, and also bring them to interact with aggregators, with the markets.
Yeah. Are you insinuating that an energy community is not always grid friendly? Maybe you can you unpack what you mean by that, and obviously there's a direction we would like to head if we are defining grid friendly. What does that look like?
For me, grid friendly means that we really support the DSO like during the whole year. And this means that we really can bring down grid investments in the long term. So because then really we save money, and when we save money, this is really in the end grid friendly for me. And this we have checked how we can bring energy communities by really good grid tariffs to support the energy community and to bring the energy community to support the DSO. And just by having a grid tariff that's connected to the capacity, to the peak load, but then have an extension for sharing between the consumers, really allowed us to bring down the overall hosting capacity, or increase the hosting capacity quite a bit. So what I want to say is good grid tariffs can really help make energy communities more grid friendly.
Thank you. I would like to come back to David to get his response, but I will, and Lola, I just want to skip you because I also kind of want to challenge, Laurence, what do you say to that? I mean, does the consumer really just need a grid tariff to be, if they are already active, is this all we need to make them more grid friendly?
Well, I mean, somebody this morning said that he doesn't comment on things he doesn't fully understand. I mean, I can't speak to grid friendliness. I'm not a grid expert. I come from the consumer movement, so I can only come from that direction. I think generally, to start a bit stratospheric, I think in many policy debates, people are always looking for this magical elixir that's going to fix every issue. But there's a couple of things that also Tara was speaking about, that Marsha and the others are speaking about, that triggered a bit some things in my brain that are things to consider in the wider debate. What consumers, if we take them as one block, can do for the grid. So first of all, I mean, it will not come as a surprise that we advocate for consumer choice when it comes to energy markets. So that people can join an energy community, that they can try flexible products, that energy sharing, that's also another element to introduce there, that they can benefit from these and that it's available to them. At the same time, we need to look, okay, what specifics do we need to look into there? And when it comes to, for instance, flexible electricity tariffs, we saw a bit in policy debates in Brussels, so not necessarily in the real world, but really in policy debates, a bit of a zero-sum game between fixed tariffs and fully dynamic tariffs. And we also, over time, because we were advocating for the benefits of flexibility, we're like, oh, you want everybody to be on dynamic tariff? No. I think EU energy regulators made it clear that actually there's a variety of types of energy tariffs out there, sort of hybrid ones, whatever you want to call it, that could be considered, and that they want to investigate, and also as an organization, we want to investigate these. I also want to go back to best practices. Marcia, please correct me if I'm wrong, but if I remember correctly, some of the Octopus products have a certain price cap. Price protect mechanism. This sounds interesting to us. It's not necessarily we're saying this should be all in Europe, but if you look at, okay, would a consumer go for something and you want to take off the edge, so to say, in terms of risk, that sounds interesting. So these are the things we need to focus on, and as a result of that, you can tackle, let's say, grid friendliness or whatever that is. But I leave that in the hands of people that understand what grid friendliness means and not in my own hands.
Sure. Maybe I love discussing definitions with people because everybody will have their own interpretation of what it means. That's the fun of being a lawyer. Lola, I might just have you pile in here. What does grid friendliness mean in the context of what you guys have been doing and studying?
Yeah, I mean, for me, green friendliness will be the way that final consumers mainly, but all the stakeholders at the end, really trust, really would like to be an active member of the grid. So for this, as I have already mentioned in this panel and years ago, to facilitate, to make trustful the way to be part of it. Also, of course, interoperability is also needed, open source. At the end, everyone should be able to be part of this. For this interoperability, I mean, in Europe, there are many types of, for instance, in our case for Eclipse, that's this common platform that is taking data from any type of energy solutions. There are many types of it, so that's why we need some interoperable solutions, some interfaces that are common to everyone, any type of data that could be integrated in a common platform all around Europe from many different types of stakeholders. That's critical, not only in the technical aspects, but also in the regulatory side. So both needs to be all together in order to be able to do this. Also an open source, as I said, everyone, it should be a solution, horizontal solution from the Commission to everyone to be part of it. And of course, to facilitate the protection of the data from consumers. As we all know, this is sensitive data. It's personal data. So the operators, retailers should be able, first of all, to provide it, but in a way that the consumers are protected, and that at the same time everyone is able to work with this sensitive data, and the other way around. All the services provided by means of this data from, for instance, from energy platforms, energy apps or platforms, should be user-friendly for everyone. I mean, we are here people that are experts in this area, but for people, my grandmother should be able also to play with an app, and to get not only financial incentives, but other type of social incentives that for so many people it's also important, and other type of recommendations in order to save energy billing.
Mm-hmm. Yeah. Maybe Lawrence, just to come back to you on that, I hear data interoperability, and the immediate question that comes, or the word that comes to my mind is trust. Because that is one of the underlying assumptions for active engagement. I need to trust that I am getting something out of this. I mean, from your guys' perspective, where are the real critical points on this at the moment?
I mean, I haven't done a full-scale survey on trust and the energy sector, but maybe to start first with your point, I also agree. I mean, as an organization, we are very much focused on digital policy as well. So when it comes to any consumer product or service, we make the general argument, data protection and privacy by design and by default, and cybersecurity by design and by default. I think this was mentioned this morning as well. What you do see is, for instance, in specific pieces of research, like the one from the UK, is that there apparently is trust in suppliers because proactive outreach by suppliers can change potentially consumer behavior. Of course, you have to then maybe look at a wider competitive area, that you don't get one provider that gets all the customers at the end. It's still good to have a market with competition. But I mean, yeah, I mean, trust is important, but I can't really speak much about it. I think it's having a hassle-free experience. Perhaps one thing that I would add into this is that researching energy tariffs can be quite complex. This comes out of multiple pieces of research, and it incurs a heavy mental load. The people that go deep, they do spend hours and hours and hours. These are maybe not the people with whom we started. These are the people that are genuinely into it. I think Bloomberg called them the home energy nerds a while ago in an article. For the other people that spend less time on it, they may not think they have the best tariff. And me living in Brussels, context, rental flat, no smart meter, so the dinosaur age of energy policy. I tried to change my energy contract a couple of months ago, you know, this whole putting into practice what you work on. And so I mailed my provider, look, according to the comparison tools, I no longer seem to have the best offer. And I got a phone call at some point back, and it was very confusing. Something about like, yeah, deductions, and I couldn't understand it. I think I'm now on a cheaper tariff, but it's still a bit unclear to me why I am on a cheaper tariff. So I think this is not too specific, doesn't have to be the case in every European country, but we do know the differences in energy markets between the European countries are still massive. I wish I could, I mean, I'm originally from the Netherlands, but my visiting my parents allows me to engage a little bit what the first speaker was saying. But there's stuff to be done there. But to say, is trust, is it something, sort of a one statement I can make about trust? No, because there's too many factors that come into play. Perhaps you've given me a new research idea for the next 2 years to look at the role of trust in the uptake of specific flexible tariffs in order to help the audience here manage their grid operations now and in the future.
Perfect. I'm doing my job. David, you raised your hand. You wanted to come in here.
Yeah, I want to add something about the tariffs, etc. So I think that finding the right tariff structure is very complicated. I agree with that, but we're talking about consumers here on this panel, and I think it's much easier on that one. And let me give a couple of examples. So in the Netherlands, we had a day and night supply tariff. And if you talk to people just on the street, they still think it's actual. And it's not anymore that case, and it doesn't matter anymore. But it's how we are brainwashed a bit in the last years. Another example is, I talked to a competitor of Octopus, and they said they've got their app, and they said, most people don't look anymore at those apps. The only way they looked in it the first couple of times to understand is what is the system asking for me. And then that's just, okay, I understand. If there's a lot of solar and wind, the prices are low. And if it's cloudy and no wind, prices are high. I understand, I don't need the app anymore. So for us, it's really difficult to find a tariff which is affordable for everybody, which does the right thing for the grid. So we can talk a lot about on these panels. But in the end, it's just a communication way to the consumer. And they will react upon that. And like Octopus is just sending an app to their consumers in the UK. Now we have to do something. Okay. So we don't have to overcomplicate how we communicate. It's complicated to find the right tariff structure. Mm-hmm. But in the end, it's just to communicate to the consumers.
Marcia, retort.
So there was one thing I neglected to say when I talked about our largest group of customers who are on Intelligent Octopus. It's a flat tariff. We give them 7 cents, basically a kilowatt hour, if we steer their EV or heat pump. We don't send the customer a price signal, but we get the price signal. We get price signals from wholesale markets, we get price signals from DSOs, we get price signals from ancillary service markets. In financial markets, customers get to choose if they want a fixed rate mortgage or if they want a variable mortgage, and they choose depending on their risk appetite. And that's where energy needs to be. You know, what's critical is we as a supplier or an aggregator is seeing the underlying signals of what's happening on wholesale markets and on grids and are buying electricity against those devices and are scheduling the devices into the cheapest wholesale prices coupled with the best time for the grid. There's only a small segment of our customers who are on agile tariff, and that dynamic tariff for customers. And actually, as the penetration of smart devices increase, those dynamic tariffs are going to do really bad things for the system. Because no one, as Octopus, if I am steering devices, I know when they will charge, and I can go onto intraday markets or day-ahead markets and buy the power at that really cheap price for those devices. On the contrary, if I give the customer a price signal and 5 gigawatts of EVs start charging at that point because I sent them a price signal, no one will have bought the power for that because no one really worked out that was going to happen. And the system operator will turn on the first gas peaker and then the second gas peaker, and pretty soon you'll be way over those cheap prices. We are already moving markets in the UK with our fleet of EVs and heat pumps and batteries. So this, and in Norway, the majority of customers are on dynamic tariffs. Is there anyone from Norgenet here?
I'll take that as a no.
So they now have a dynamic day-ahead grid tariff to counteract the impact of the dynamic network tariff, the dynamic retail tariff. So you need to be sending the right signals, but you need to send them to the people who are actually buying and selling and managing the stuff, because it's only the people, you only want the people who are managing the devices to be seeing those price signals. Does that make sense?
David, would you like to respond to that?
Yeah, so I understand what's going on, because it comes back to the discussion we had earlier on. We didn't go into like the difference between what's good for the grid is not good for the energy markets. Sometimes there's a difference in that. So I do understand this, and I think it's really depending on also on what the consumer wants in the end. So the biggest question is here, who's giving the autonomy to whom is the consumer giving autonomy? So I would argue that in some countries people don't give autonomy to the supplier, even to another supplier. They want to do it themselves. What I fully agree with is you have to account for the risk appetite of the consumer. So at the moment, for example, in the Netherlands, the majority wants fixed contracts on everything. Just no end of discussion, no difficulties, etc. And then we have to change something on that, because we also see if we don't do something on there, we don't come to the flexibility we need. And it's okay for me if we don't get to the flexibility, but then we have to accept that it has a counterside on your bill, and on the way you have to wait before the grid's ready. So there is an optimum, and there's a difference between the we and the me on this one. And the way you get there, that's okay for me, and it will depend on the consumer, whether it's Octopus or the consumer itself, but we have to change the behavior in the end, and people have to know what is the right behavior. That's what we have to communicate.
I think it's the difference between me and we. Maybe I'll give a last word to the three speakers here. Maybe you want to say something about that. Tara, I'll let you go first.
I think I need a micro. Yes. I think the discussion just showed what I wanted to say. We need to make it simple. We need to consider the markets, simple and autonomy, consumer, market and grid, and to bring it in the end together, that it works. And yes, so, and I think for this point, I think we are all here on the podium on the same side.
Yeah, also as a conclusion, apart from being simple and and easy to use for final consumers. Also the importance of the interoperability of the energy systems, the availability of the data, and at the same time the protection of this data, and to be as trustful as possible for final users, transparency, and to be all together win-win for everyone, and it will be mainly the only way to arrive to this energy transition.
Okay. And Lawrence, I'll let you send us off.
Well, I honestly think everything has been said. I would just echo what David said. And, let's look into risk appetite. Let's look into these factors. The modeling and everything has been done. The business cases are there. Let's move forward and bring it to consumers, to those who want it, of course.
Great. All right. I think we have managed to stay within our time. And I think we've kept it lively enough. I sure hope so anyway. So thanks a lot for sticking around for this panel. And let's give our panelists a last round of applause. All right.
Thanks, Josh.
Thank you, Josh. I have to close this off. Wow. So talking about innovation, I think this is the first time we had this conference, and at the same time, it's not the first time we have this conference. So this sounds a bit strange to say as the first words, but this is the first time the FutureGrid Innovation Summit, and before we had, of course, the InnoGrid. So I think this was a very, very interesting day if I talk to for myself. And I think I want to reflect a bit on today, and I think for me, especially around lunch with the IEA, was like, how do we ensure that as Europe that we remain competitive in the global energy transition? I think it was one of those slides that popped out to me, like you think you're really busy on the smart grid, and then you see that you have to be in Japan. And think, oh, I didn't realize that after seeing those slides. So that's, I think, the key question for me. How do we remain competitive as Europe? And I got a couple of lessons on this one from today, and I want to share with you. And don't worry, I won't be Philo Castro on here. I know you have to catch planes, and I want to go to a drink or something like that, so I will keep it short. I think the first one, first of all, is the innovation and flexible grids. I think Europe's energy infrastructure should be at the heart of the competitive advantage. I think Europe is investing heavily in grid expansion, but so is the rest of the world. We are investing heavily in smart grid solutions, storage, flexible market designs. We saw but so is the rest of the world. And I think, we heard it in the panels today, that if we want to stay ahead, we must move beyond the pilots, and we have to move up to large-scale digitalization. And not only in countries, but across countries in Europe. I think it was really clear for me today. And I really liked all the examples about AI-driven congestion management, but also we talked about open data, and I think we really have to find ways to scale these innovations, not only in countries, but also across countries. I think secondly is about consumer empowerment, also the last panel. I would state that a competitive economy, if we want to have a competitive Europe, we need active market participants. And this is really about a paradigm shift. And I think we also need to talk about business-friendly or consumer-friendly energy systems. If we can enable all the users of the energy grid, all the participants in the ecosystem, we are able to get the system as cheap or affordable as possible, and that's really crucial for a competitive Europe. And I think to do that is that consumer empowerment will go hand in hand with stability. We talked about resilience today. And I think resilience is key, but also then we need consumer flexibility, industrial flexibility. And to do that, we need smart pricing mechanisms, we talked just about, but also interoperability is crucial to get it, but also transparent market signals. And if we get this, we can compete globally, I think. But it's difficult to get the balance right. It's a new balance in the way we deal with energy, as companies, but also as consumers and as industries. And I think the third one is around demand-side flexibility and system stability. And I think demand-side flexibility is, we talk a lot about this in a way from the grid, but I think this is not only an energy issue, it's also an economic imperative. If I see the analysis and we want to make sure that we are secure but also cost-effective, our uses of electricity need to be flexible. Prices will really vary. And so for me, demand-side flexibility is not only about grid-friendly flexibility, but also an economic imperative. And that's also, again, a system change for me. It helps the grid, but it also helps the competitiveness of Europe. And then I would like to conclude with a final thought. And for me, that's really from innovation to execution. I really think it's really time I should have bring my helmet and roll up the sleeves again, and let's get to work. I think we know a lot of the technologies there, but it's really about the interplay with the technologies and the signals to get used these technologies. And my final thought would be that competitiveness is not a given, and we have to build it. We heard baby build, somebody said today. I think it's also not about the grid only. It's really crucial. We need to strengthen the grid on a lot of sides, but it's also about competitiveness. It asks daily work. And I think Europe has the talent, the technology, and the ambition to lead the global energy transition. But as we have discussed today, I think this also requires leadership and action. And I think we really must move from pilots to large-scale deployments in countries and across borders. And I think consumers' empowerment must be backed by smart regulation. We talked about regulation this morning. Market design we talked about. But we also must not only strengthen our grids for 2030, but for the future of Europe. So it's also after 2030. And then if we are able to do that, I think Europe can remain as a leader and not as a follower in the global clean energy race. And I think that's the perspective which comes out to me from today. We have to act, and we have to move up from innovation to action. But if we succeed in this, there's a role for us as Europe as a leader. So I think that's the perspective I would ask you to bring home and think about how do we get there and make the impact real. And before I want to send you home or to the drinks or to your plane, I have to thank a couple of people. And I want to thank our sponsors. They're already there on the banner, but you've seen them today, APRI, Over IT, Prismium, the event partner, Energyville. I want to thank the EU projects, Be Flexible, Copper, Eclipse, and Twin EU, which were on stage also today. I want to thank you, all the participants, you there. But I really want to thank the team here of E.DSO, organizing everything here together. Thank you very much for today. It was a very interesting day.